Hello, and welcome to the Teleport for Kubernetes course. I'm excited to walk you through everything that you need to know to deploy, configure, and operate Teleport as the access layer for your Kubernetes clusters. Over the next 6 videos, we are going to go from zero to a fully working setup, identity-based access, role-based controls, just-in-time privilege escalation with full audit logging. Everything that you need to lock down Kubernetes access the right way. Now, before we build anything, we need to understand the problem that we're solving. So let's begin. If you've been working with Kubernetes for any amount of time, and I will assume you're watching this video, so of course you have, then you're familiar with kubeconfig files. They're the standard way to authenticate with any Kubernetes cluster. You get the file, you drop it into your home directory .kube/config, and off you go. You can kube control your way into all the problems in the world. But have you ever looked inside of a kubeconfig file? So let's start by taking a look at one now. All right, so let's take a look. This is an example kubeconfig file. Like everything in Kubernetes, we have a kind and an API version. The kubeconfig is no different. A kubeconfig can host a configuration for one or more clusters. So as you can see, we have clusters, which is a list. This will have the server, the IP address or hostname for your API server. And you'll have some sort of base64 encoded CA certificate. You then have multiple contexts, which can span multiple clusters and multiple users. And then, of course, we have our users. Well, Kubernetes has no real concept of a user. It does have some ability to authenticate with the cluster. Now, these certificates are not special. They're just X509 certificates with issuers, subjects, not before, not after, all the basic stuff you would accept from any standard X509. So typically what you will see is that your kubeconfig has some sort of long-lived secret. Typically, these live for months or years. There's also no ability to revoke these certificates unless you change the root certificate authority within your cluster, which is no easy task. The subject is always very generic, kubernetes-admin. Again, there is no concept of users within a Kubernetes cluster. Now, while you may not always get system masters with root access to your cluster, when you spin up a cluster on your cloud provider of choice, this is typically what you are given. And again, revoking access means rotating the entire certificate authority for your cluster, regenerating all your certificates. This is hard. And in our AI landscape, when you have your kubeconfig living as a file on your disk, your AI agents potentially have access to all of your clusters as well, including production, with the same authentication, the same capabilities, the same role access that you yourself have. Now, what about the audit gaps? What do I mean by audit gaps? Well, Kubernetes does have audit capabilities, but they only work well when every user has a unique identity. When everyone is sharing that same Kubernetes admin identity, it's hard to tell who did what. Here we have the real kube control get events from one of my production clusters. And as you can tell, there's no concept of who did anything. We can see pods being scheduled, images being pulled, containers were started, but not who created anything, which user ran kube control exec, what commands are executed inside of a shell session. Right? We all have the ability to run kube control debug and kube control exec. And there's no why for anything was scaled. Why did we change the replicas from 3 to 0, right? Where we performing some form of maintenance. All of this context is lost. Now, Kubernetes does have audit policies and audit logs that are a bit more verbose. But again, if we're using X509 certificates provisioned by our cloud provider of choice, and that's typically just giving us the Kubernetes admin access to the cluster, we're losing out on a lot of very important information. We lose out on the who, we lose out on the why. All we get is the what. So I think we've covered the problem space well. Now I want to show you the solution. Have you using Teleport since 2018. And in fact, every episode of Cluster that has ever aired has always been powered by Teleport. Now, in case you're not familiar with Teleport, Teleport is an infrastructure access platform. It sits in front of your infrastructure, Kubernetes clusters, SSH servers, databases, web applications, you name it. It provides a single, unified layer for authentication and authorization with complete audit capabilities. The core idea is deceptively simple. Instead of handing out long-lived credentials, Teleport will act as your certificate authority. When you authenticate through your company's SSO, something like Okta, Google Workspace, or even GitHub, Teleport issues you a short-lived X509 certificate. This certificate contains your real identity, your roles, and an expiration time. By default, certificates are valid for around 12 hours, and when they expire, you have to re-authenticate. It solves, or at least mitigates, the problem of long-lived credentials, where there's no ability to revoke, and doing so is a painful cluster-wide operation. Teleport provides us a zero-trust model. No standing credentials, no shared secrets, and every access attempt starts with a fresh authentication event that is tied to a real human identity, or perhaps a robot. We'll get into that later. For Kubernetes specifically, this means that when you run kubeconfig get pods, the request carries a certificate that says, "This is David Flanagan. He has the dev team role, and this certificate expires in 11 hours. The Kubernetes API server sees a real identity, the RBAC policies attached to me, and those can be as granular as we need, as we will see throughout this course. And now your audit logs contain something actually meaningful that helps you triage when a time occurs. Teleport is open source. At least the community edition is completely open source and free for anyone to use with GitHub-backed SSO. And it's what we'll be using in this course. Now, of course, there is an enterprise edition and a cloud edition that supports features like SAML connectors, hooking up to Okta and Google Workspace, HSM support, and the Teleport policy engine. So if that's of value to you and your company, click the link in the description below to learn more. But please bear in mind, everything we build in this course works with the community edition. So now let's talk about how Teleport actually works under the hood. There are 3 core services, and understanding how they interact is essential before you start deploying anything to production. First up, we have the auth service. This is the brain of Teleport. It runs a certificate authority that issues and assigns all certificates. It stores a cluster state, users, roles, connectors, trusted clusters, and it writes to the audit log. Every authentication event, every kubeconfig command, every exec session gets reported. The auth service should never be directly exposed to the internet, and it sits behind the proxy service and communicates over MTLS, the way modern secure applications should communicate. So then the second service is, of course, the proxy service. This is your public-facing gateway. It's what your users actually connect and speak to. When you run TSH login, you're talking to the proxy service. It handles protocol detection and routing. The same port can serve actually the web UI, SSH connections, Kubernetes API requests, and database connections, depending on how far you push your Teleport adoption. This is done through a feature called multiplex mode, where a single port, usually it's 443, handles all your protocols. And it's one of my favorite features. The proxy service authenticates incoming requests and routes them to the appropriate backend service, which introduces us to service 3. In Kubernetes service. This is the agent that connects Teleport to your Kubernetes cluster's API server. It can run inside the cluster as a pod or outside the cluster pointing in. The Kubernetes service maintains a reverse tunnel back to the proxy service, which means that your Kubernetes API server never needs to be exposed to the internet. Traffic flows into the proxy, gets routed to the Kubernetes service through the tunnel, and the Kubernetes service forwards it to the API server using its own service account credentials. All of this complexity is handled for you if you use the Helm chart, which we'll be covering soon. And the main takeaway from all of this information is that every step, every flow when you use Teleport to access your cluster is authenticated with mutual TLS.
every request is logged. And the entire chain is based on a certificate that expires in hours and not months. And in this course, we're going to run everything in a kind cluster on your local machine. We need to try this right now. We're just following along with this course and typing the exact same commands that I am typing. Don't worry if you don't have domain names and cloud infrastructure to throw at you. We're keeping this super simple. So what can you expect over the next 5 videos? Well, we're going to walk through a production deployment using kind still locally, but making sure we cover the considerations that you need moving this into your real production infrastructure, such as Cert Manager, deploying Teleport with Helm, and accessing the web UI through SSO. We'll be using GitHub as our identity provider because it is available on the Community Edition. That means we'll be mapping our GitHub identities to Teleport roles and showing you how to use CSH login and removing kubeconfig from your life entirely. We'll be using Kubernetes roles and federating this with Teleport roles so that they work together. You'll see how to give developers read access to one namespace while blocking access to everything else, and how Teleport can enforce this through its short-lived certificate groups. As we progress through the rest of the videos, we'll be taking a look at access request and just-in-time privilege. Again, another one of my favorite features. We'll be implementing a workflow where no one has write access or admin access to a Kubernetes cluster, but showing you how your engineers can request elevated privilege that can be approved by one or more people within your organization. And then we'll move in to Teleport's audit log, where we actually have the ability to re-watch sessions, even when they're using kubeconfig exec. Every video in this course includes runnable demo scripts that you can execute in your own machine. Everything is publicly available in the Raw Code Academy GitHub repository, and linked in the descriptions for each video. I strongly recommend that you follow along. This material does stick much better when it's tactile, when you're building it for yourself. All right, that is enough of the talkie-talkie. I've given you enough information. You know what to expect. It's now time to make things happen. I'll see you in the next video as we deploy Teleport from scratch.